I am going to talk about Lambda functions and one application of them. This is only scratching the surface of Lambda functions because I have recently learned about them. And first, we'll talk about how we might write one. And then next, I'll give an example of a use case for them. So what is a Lambda function? It is a function that differs from the types of functions that we've been writing over the past few weeks in a few different ways. I'm not going to go in depth on all of the ways, but I will start us off with one way in which they're different is that they are anonymous. So what do we mean by anonymous? For example, if we take a function that is similar to the ones we have been writing, like let's say this would be a named function where the function has a name. In this case, it's add numbers, it takes arguments, it takes parameters x, y, and it returns x plus y. So there's a different way in which we could write a function that does the same, but doesn't require us to give that function a name. And the way in Python that we would do it is that we could write Lambda, as in LAMBDA. We tell it what should be the arguments of this function, colon, and then we write the expression that we want to evaluate. So for instance, in this case, we would write Lambda, the arguments x, y, and then colon, and we want to evaluate x plus y. Both of these on the right and the left will return us x plus y. So next we can look at what would it be like if we were to supply specific arguments to this function? How do we use that to evaluate some specific set of arguments? And the way that we could do that is this. So because this function is not named, we see we have to write that function. The syntax is that we put it in parentheses, and then we tell it the arguments are 1 and 2. And so in this case, when we run this, the return would give us 1 plus 2, which is 3. What are some reasons why people might want to use this sort of function as opposed to this function? This is perhaps a topic that comes with some controversy, and I'm sure that as all of us go on in our careers, we will develop our own opinions and coding styles. There are certain use cases that I have only started to scratch the surface of, so I'll just go on to talk about maybe one consideration, which is that we see here that this function, it only takes one expression. And if we think about functions that we've been writing, sometimes we're evaluating multiple expressions within that function. So one limitation of this could be that you can only evaluate one expression. When we think of a situation in which we, let's say, want to write a simple function and we don't plan to call on it again and again, and so we don't see a need perhaps to give it a name, then that could potentially be a use case for it. And specifically, if we think about that, there are functions that take other functions as inputs, and those would be called higher order functions, where it can take another function as an input. And that can be a use case where we would use a Lambda function. So I'll give one example. Let's set up a hypothetical situation in which, let's say, we took a class field trip to an island that sells melons. And on this island, once a melon is given a price, it stays at that price forever. We love it. We always know what to expect to pay for our melons. And when we come back from this trip to Minnesota, we're so amazed by that we want to make a stone tablet where we engrave every melon that we saw and its price. And it's really important for us that those get listed on the tablet with the price from low to high. However, the challenge is that, let's say, our information comes in a way that is not shown with the prices low to high. So we think, oh, well, we know a sorted function. Let's think about how we can use that. So a sorted function is an example of a higher order function where it can take another function as an input. If we remind ourselves, the sorted function takes parameters of an iterable, which is required, and then 2 optional parameters. One is called a key, and one is the reverse, which does ascending or descending order. So the key is where we can put in a function, and we can tell the sorted function, in a sense, we want you to sort by evaluating what we put in the key, and in a sense, using that as a, let's call it proxy value for how we want to sort. So if we take this example, let's say we have a list, it has a melon and has a price in a tuple. And as we can see here, the items in the list are not ordered. We see 1.75 is last, even though hypothetically we want it to show up first. And let's say this list is very short, we could eyeball and order, but let's say, we were so dazzled by our island field trip that we no longer have that ability, and we need the sorted function to help us. So if we were to do sorted melons and prices and say create a variable to store that, what it will give us is that list where it's sorting by the value at index 0 in the tuple. So by alphabetical order in this case, where we get crimson and then jubilee, moonbeam, and tender gold. And we see that the prices are not in order because this melon at 2.5 comes before this melon at 2.25. So we might think, what is a way that can help us? So if we consider a proxy for a tuple's order in this list, like it would be great if we could tell the function, hey, can you pretend that this tuple, Jubilee Watermelon 2.5, is in a sense represented by 2.5? And can you tell the function that this tuple, Moonbeam Watermelon 2.25, is in a sense represented by 2.25? And if you were able to think about that, then we would see that, oh, hey, we know 2.25 should come before 2.5. So for this purpose, I'm going to call that, let's say we want to use the price as a proxy value to refer to this tuple, and then tell it based on that, give us the ordering. So step 1, we can think about how to use Lambda function to write a function that takes in a tuple and gives us that price. So in this case, we might have an example tuple, Moonbeam Watermelon 2.25. And we know that if we take tuple at index 1, it will give us 2.25. So if we generalize that to how would we write that in a function for every tuple, we could say lambda, where x is the parameter and x here is this tuple. And we want to get x at index 1 so that we get the price. So this is a function that takes in the tuple and gives us that value that's at index 1. And now if we think back to the sorted function, we can put in this function as the key. So we would say, for instance, we want to sort those melons and prices, that list, where the key is this function that returns the value at index 1 from that tuple. And then if we do this, and then we look at what is this new list that we have created based on this sorting, then we would get the melons so that they are sorted by the price, right now sorted ascending, instead of sorted by the name, which is the other value in the tuple. So I'm sure that we can all probably start wondering about their creative ways to use the key. Like there are many sorts of different functions we could write to put in here that help the sorted function to know what do we want to sort on. So I am excited to know what you all think. And if you come up with creative use cases or start thinking about what ifs, I'd love to know.